Hey guys, it's Wade here. Today is elevator day. It's 95 degrees in this shop, so I'm going to try to get through this video as quickly as possible, which many of you know may be a little bit of a feat for me. So, what am I doing today? Weight and balance. I've weighed both of the elevators, left and right. These are Roncz Canard elevators, and that comes into play. And then I've also right here I've got it set up on these 90-degree angled aluminum pieces for the quote-unquote knife edges. Now the weight and balance of these Roncz Canard elevators was spelled out not just for the Roncz Canard but also for the GU, and there was an incident, and I don't remember exactly when it was, maybe late 90s early 2000s, of a very easy in Southern California that had rebuilt its elevators. It kept the original elevator and embedded that into a longer cord elevator, and that experienced flutter and it destroyed the Canard. Canard parted the aircraft and the two people in the aircraft crashed. So that got Routine Aircraft Factory to start discussing mandatory grounding of Canards unless people check their elevators for weight and balance. So what I'm going off of is Canard Pusher Newsletter 108, and this discusses specifically, as you can see at the top, Long-EZ elevators designed to mount on the Roncz Canard. 106 and 107 discuss the problem, but they kind of focus on the GU somewhat. Now the GU numbers for the left elevator, max weight is 3.9 pounds. For the right elevator, max weight is 3.5 pounds. Now on the Roncz Canard, as spelled out in this highlighted area here, which I'll read, it says it is RAF's, Routine Aircraft Factory's, recommendation that any Roncz elevator, parentheses, after it has been balanced to the pivot line. Let me explain that really quickly. If this does not balance the way it should, and I'll go through the procedure, the process, you're allowed to put up to 0.3 pounds on the outboard weight to get it to balance. However, as you'll listen, if you listen to this, it is RAF's recommendation that any Roncz elevator, after it has been balanced to the pivot line, which is that 0.3 pounds, that you're allowed to add, which would mean that you started out with a really light elevator, but for some reason it's very off balance, which would be strange. That weighs more than 3.8 pounds left and 3.4 pounds right should not be flown. Okay, so I'm going to tell you my numbers really quickly, and then I'm going to give you a caveat, and then I'm going to dice the numbers just a hair. Not trying to quibble here, just trying to get into my particular situation. So this is the left elevator for a Roncz Canard, my Roncz Canard. It weighs 3.48 pounds. Now, according to this, I'm fine because it needs to be less than 3.8 pounds. However, I have a little bit of a different little wiggle going on here in the fact that I am not using the original NC, it's November Charlie -12A weldments that's called out in the Roncz Canard plans. Now, the original might be NC12, don't quote me, and then Roncz Canard is NC12A. I didn't delve into it that far. But what happens is on the left side, both on the GU Canard and the Roncz Canard, as far as the elevator, the left elevator, this arm right here with the weight on it is all the way over on the right side of the aircraft, just inboard of the right side elevator's arm, and then they pretty much match up, and then a bolt goes through both of these down rods, or these angled arms here, to attach to the elevator control tube that goes to the control stick. So that is about this long. The reason why I say that is because I bought both the original right shorter control tube, mounting tube, for the right elevator, and then this was actually originally part of the left elevator. I might have bought another piece and Aladdined it, I don't remember, but it's essentially, if I added this to this end right here, that's how long that would be. Now, why is mine different? The Cozy Girrls sell a weldment or a torque offset that is designated the MK-NC-12A. Now these are often used in cozies, and what happens is in the Long-EZ there is an eccentric action going on which creates a bigger slot on the side of the fuselage right just after the canard, down below where you're getting the movement here of this piece. And so because the piece doesn't just rotate concentrically, it moves down and up with the movement of the elevator as you move the stick forward and aft, and that creates a slot in the side of the aircraft, which many people have complained about the significant amount of air, especially when it's colder weather, coming into that slot. What the Mark NC-12-A does is it eliminates that. You have the eccentric movement still, but that's out here. But right here where it goes through the wall of the aircraft, you have a concentric movement which just rotates without any pivot. And here is the original plans that you can see with the kind of channel or slot that has to be made with the original NC-12 or NC-12A. And then here is a picture of my aircraft, both on the right side, but especially if you look over on the far side, on the left side, you can see that there's just basically half a hole and then half a circle. And then the other half of that is on the canard that literally plops down and just goes around this point right here. And so I have a very little gap there. And so that's the main reason why you would do that. I also have electric trim, so I don't have the V-shaped arm that goes right in at this point, just inboard on the left side. So my system is symmetrical. So now that creates a little bit of an issue, because how do I weigh these things out? This is originally on the Roncz elevator, good to 3.8 pounds, but I don't have the original configuration with this sticking out all the way over, and then I don't have the weight here over on the right hand side. But if you add them together, just an intuitive swag at the beginning, you have underneath the original plans, if you maxed out the exact weight that you could have per CP 108, this is page 4, then you would have 3.8 pounds on the left and 3.4 pounds on the right for a max of 7.2 pounds total from one end of the elevator on the left all the way to the right. So what I have is I have left, and bear with me here, 3.48. Right is right at 3.4. And then this center tube with the hardware is just under 2.3 pounds. So that gives me total weight from one end to the other at 7.11 pounds. So I'm actually under in total weight. So if you split it just in half, I'm good, because 7.2 pounds, split it just in half because I have a symmetrical system, you're talking about 3.6 on each side. Now, I'm not an engineer, and maybe the original value for the left elevator at 3.8 for the Roncz Canard is because it's got this torque tube extending over all the way to the right sidewall, and then it has this weight right here. But however, if we're going to play that game, because we're looking at the weights, then I will tell you that this torque offset, the way it's welded up, this right here, which is basically a thick tube, is what's inside of here. This is hollow. This is almost solid with a slash cut through it. And this is 4130 steel. So all of this inboard of this torque offset with this chunky piece right here, again, solid 4130 right there, which is kind of like the aluminum pieces. If you've made up a Roncz elevator, you know that we embed one in the middle and then one at the end down there of these basically blocks that slide in, so that that's the hinge point for the attaching the elevator to the canard. Anyway, this unit right here, this offset, weighs, without the hardware and without the lead, weighs 0.52 pounds. Now, if I take 20% of that that's inboard, and I take that weight which is 0.1 pounds, and I subtract it from the 3.48, now I'm at 3.38. So why am I saying all this? Because given the weight of the center torque tube with the hardware, which is just under 0.23 pounds, I'm making a command decision that at 3.48, if I minus this, and I'm not trying to be cute, and then I'm going to show you the balancing of these, and then we'll move on from there. So I'm going to read this pretty much verbatim as I do it, and I'm going to explain it. There are some typos in here. Again, Canard Pusher newsletter, number 108, page 4. That's the title. The outboard knife edge should support the elevator under the protruding stainless hinge pin, which is this guy, if you can see it right here. It's also sticking out the other end, close to the outboard end of each elevator. The elevator should be upside down. This is the underside of the elevator right here. Use your fingers to hold the trailing edge such that the bottom skin is level. That's about level right there. Gently release the elevator, and if it is correctly balanced, it remains in this position or it falls nose down. So that fell nose down. So that is well balanced, as you can see. The elevators are not flight worthy if they fall trailing edge down, which this is the trailing edge. Obviously it went up. So this is the left elevator, and it balances, as you can see, very well. All right. We're going to move on to the right elevator. All right, sports fans, here we have the right elevator set up. Again, I'm going to point out this torque offset. This is a hollow tube. This is a solid chunk right here of 41. This is all 4130, but this is a solid chunk of 4130 with a slot cut out of it. Hollow tube and another hollow tube there. 5.2 or 5.3 pounds. And then again, if I just took 20% of that for this sticking inside, and then not even allowing, you know, if you allow for some of the weight of the interior torque tube, that's at least 0.1 pound that if we allow for that. But this is 3.4 pounds. It's like 3.403 pounds, and we're gonna check the balance, and I'm going to read this again just to make sure we're clear. This is again out of Canard Pusher newsletter number 108, page 4. The outboard knife edge should support the elevator under the protruding stainless hinge pin close to the outboard end of each elevator, which we have here. The elevator should be upside down, which it is. Use your finger to hold the trailing edge such that the bottom skin is level, which it is. Gently release the elevator, and if it is correctly balanced, it remains in this position or it will fall nose down. Okay, so here we're level. And we have trailing edge up. The elevators are not flight worthy if they fall trailing edge down, exclamation point. And so as you can see, both of my elevators are very well balanced. And then because of these MK November Charlie -12A torque offsets, it threw a little bit of a wrinkle into how I'm evaluating the actual technical weight for each side because I have a symmetrical setup. This is a big milestone. And again, I'm making a command decision. I'm sure there's going to be some lively discussions, quite possibly in the comments below, which I welcome. But this is it. And then I'm moving on to the ailerons, which I almost guarantee I'm going to have to add, at least on one side, some lead weight to those to get those to balance properly after paint. But that's it. Thanks for watching. Cheers.